All right, so we're starting with going over the matching section on 2.20 because I told you to have it done by the time you walked in tomorrow. Like you have some time during the announcements to get it done. We have to keep moving on. And I do think that this is good practice before your quiz that you're going to take. So you're going to take the quiz the second half of class. So at 10, wherever we get to, we're just going to stop and take the quiz for 18 to 20. So we will start lesson 21 today. That's why you picked up the note sheet for 21 today. But this, what's on the board, is from yesterday, the 2.21. So I showed you how to solve these algebraically, which you do have to know how to do. But I also show you how you can check your answer. How can you check your answer? Through Desmos. So don't 100% rely on it because you still have to know how to find the error and things like that. But you can just type in the problem. So I'm copying example number 1. 6x less than or equal to 3. Right, so just typing it in, and then you also have to be able to interpret it. So where does the shading start at? What x value? 0. So that means when I solve this, it will be x compared to 0, and x is anywhere that it is shaded. So what's shaded? Numbers that are bigger than x or smaller than x? So x has to be smaller than 0. Can it be exactly 0? Yes, and you can tell 1 because there's an equal to underneath there already. And 2 because it creates that solid line, which is like that closed circle. That is not. And then, yeah, if I were to solve this algebraically, I would get the same exact thing. So use that to verify your answer. So then to figure out what best matches it, where would my dot be on the number line for this answer? Which, if any of these, have a dot on the 0? Just graph F, right? So graph F goes with number 1. If there were multiple answers that had dots on the 0, then I might have to look closer. This symbol would be an open or closed circle. Good. If it has the line underneath, it's a closed circle. Because it includes that number in the answer. If it doesn't, then it's an open circle. So yeah, this one definitely has a closed circle, and it does cover, has the arrow pointing to where the numbers are less than 0. So that's why it matches. Make sense? All right, which other one do you want to see worked out algebraically? We're not doing all of them. Because especially if you have to use Heisenberg, we're definitely not doing all of them. Sorry, what was that? E. So which of these numbers? Okay, so let's review number 5, and I think that's a great one to review because you'll see a problem just like that on your quiz, on your Unit 2 test, on your constructed response with your Unit 2 test. That's a good one to go. So 4x minus 1 over 3 greater than -1. Continue to go through all of those steps that we went over in lesson 19. So do I need to distribute in this problem? Do I need to combine like terms in this problem? Do I need to move the variables to one side in this problem? No, it's already on one side. But you still check for that in that order every single time. Is there any questions about this? And don't interrupt me while I'm okay. Random. So then the last step is just to isolate the variable. And I always say start with what is farthest from the variable. So I don't mean like on the other side of the symbol. I mean on the same side, because we want to eventually get the x by itself. So out of these three numbers, what's farther? The 4, the -1, or the 3? But it's physically farther. The 3. This one, the 4 and the -1 are on the same part of the fraction. This one's on the other side, right? So you would cancel that out first. How would you cancel that out? Not by what's on top.
Oh, I mean, what by 3? You multiply the 3 with x. What I mean, yeah.
You would multiply by what's on the bottom, right? Because isn't like if I had 9 divided by 3 and then times 3, doesn't that undo what we just did? Yeah, I would just get 9. So that works to break up any fraction, multiply it by the denominator. But whatever you do on one side, you have to do to the other side. So then on the left side, I just have the 4x minus 1. Do I need to flip the sign for that? No, because you just multiplied a positive number. -1 times 3 is -3, and then you keep going. Now it's farther from the x, so 4 or the -1. How do you cancel that out? Whatever you do on one side. And then that cancels. I have 4x greater than with -3 plus 1. And then opposite of multiplying by 4 is whatever you do on one side. Do I need to flip the sign for that? I do not. It's what you multiply or divide by on each side. So just because there's a negative here doesn't mean like I flip it. It's what you had to do on each side. Is that for a positive or negative? So that's what makes it. And then what does -2 over 4 simplify to? Good, -1/2 or -0.5. Same thing. Questions on that process? All right. So then find the number line that matches that. So where would the dot be? Between the -1 and 0, which graph? All right, yes, and that's the only one that has it on that number. So yes, but if you had multiple on that number, look more closely, that symbol would have an open circle, and if it is greater, like the x is bigger in that relationship, it would point to the right. So questions on that one? That a million times. We'll see problems just like that, where you have to break up the fraction by multiplying by the denominator. Which other one do you want to see algebraically? Like from the ones on the left, which ones? Okay, 6. So then number 6 we'll go over. Hopefully the others are manageable enough. We've done a lot of examples like the other ones. But now go through your steps. You don't have to distribute. Don't have to combine like terms, because this one has an x and this one doesn't, so they're not like terms. Do I need to move the variable to one side? Yes, I shouldn't have variables on both sides. Now, there are multiple ways to solve this. I'm thinking that the best way might actually be to, which one do you want to move? I'll leave it up to you actually. Do you want to move this X term to the right or this X term to the left?
To the left.
Move this X to the left?
Yeah.
Okay. How do I cancel the X on the right side? Subtract X, whatever you do on one side. Now, what number is in front of the X if it's not written? So really, I have a negative 1/5 X. So it's negative 1/5 minus 1X. That's what you guys did. So let's put that in our calculator. Unless you happen to know how to do it by hand. What was it? Negative 1/5. And normally always put your fractions in parentheses. I didn't do it that time. Maybe I'll just throw them in. And then we're minusing 1. All right, it gives me a decimal. If I need the fraction, click the fraction button. I think the decimal will work since we have to plot it on a number. The questions on how we got this number? Okay, so then on the left, I still have that 12/5. On here, it became negative 1.2x less than or equal to what's x minus x. No, it's 0. X minus x is 0. So then keep working to isolate the x. How do I cancel the 12/5? So I don't want it to become 1. Multiplying it by the reciprocal would make it 1. I want it to become 0. Subtracting. And then whatever you do on one side, you do to the other side. And then that cancels. I have negative 1.2x less than or equal to negative 12/5. I think I'm actually going to make that the fraction form. So remember, if you need the fraction form, press that button. I'm going to make it negative 6/5, which is the same thing as 1.2. And now if I want to cancel the negative 6/5 times the x, what would I do? Yeah, well, yes, you want it to cancel out. By multiplying by the denominator would make it negative 6x. So then you still have to keep working. There's something we can do now to get rid of it in one step. Multiplying by the reciprocal. So multiply it by 5 over negative 6, whatever you do on one side. Good. If you don't like fractions, put it in your calculator. Make sure that you put it in parentheses. So then, all right, parentheses, negative 12 division times 5 times parentheses 5 over negative 6. Sorry, backwards arrow out of it. All right, I get 2. Sorry, I know that was a lot of work, but that's the process. I'll follow all the same rules. You just have to know how to use a calculator. So 6 should have been x less than or equal to 2. Which best matches graph B, you said? All right, let's see. I agree. So 6 is graph B. Right, Gray, what did you need? All right, then let me tell you the answers for the others, just so you can see if you were right or wrong. They should have already been done. Which one best matches number 2? Graph E is correct for number 2. That one was x greater than -2. What about for number 3? What graph? So actually, you guys earlier, hold on. Number 3 says graph B. So let me see, graph 6 should actually be C, and I remember why. What did we forget to do in number 6? We forgot to flip it when we multiplied by that negative. So flip the symbol in number 6. Sorry, see, it happens. So you got to ask yourself every time if the symbol flips. So then 1 was F, 2 was E, 3 was B, 4 is D. Graph D was x less than 1/2. 5 we said is A, 6 is C, which it should be x greater than or equal to 2. All right, questions, comments, concerns? All right. So now we're going to move on to lesson 21, the note sheet you picked up today. Good? All right. So then lesson 21. The goal for that lesson is to graph linear inequalities in 2 variables. So what does linear mean? Like what formula is for linear? We did it with equations not that long ago. What's the formula for linear equation? Hey, y equals mx plus b, good. Or the standard form. All right, both of those forms make your linear equation. So now it's linear inequalities that we'll be graphing. So inequalities are basically the opposite of what? Equation. So what are my inequality symbols? Greater than is one of them. Less than. Greater than or equal to, and good. So that's what we're doing basically. Now instead of it being an equation, it's going to have one of these symbols. And we're going to have 2 variables. So here's a math talk. We haven't done one of these in a while, so let me remind you how they work. You don't shout out the answer. When you have the answer, you just put your thumb up, and then we can mute, call and mute as I call you. You should avoid scratch work. You should avoid using a calculator. But when we go over it, definitely take notes on it. So try to listen to the strategies for how other people were able to do it mentally. But here's the problem, and it is printed on your paper. This is an expression 2x plus 3y. And you're going to decide if each ordered pair makes the value of the expression less than, greater than, or equal to 12. So we're trying to figure out what symbol to put in between this and 12 based on the ordered pair. All right, so here's the first one, 0, 5. Would it be less than, greater than, or equal to 12? Just put your thumb up when you have the answer. Don't follow. All right, Allison, what do you think goes between them? Good, and then you add them together and it's 15 greater than 12? Yep. Yeah. So yeah, greater than does go in between them for the first one. So try to use other people's strategies. You need to remember in the coordinate form, what comes first? It goes in the order X, Y, right? So you just plug it in, do your math, and then get your answer. So now here's the next one. What symbol goes in between the expression in 12 if the coordinate is 6 and 0? Right, just sum up when you have the answer. All right. Peyton. Oh, sorry, we're good. Is there 2 Peytons? Oh. Or you're Christian Peyton, right? Okay, sorry. That always confuses me when you have last names that can be perfect. All right, but still, anyway, sorry. Other Peyton. What'd you say? Equal to. And how did you figure that out? So 2 times 6 is, and then what about the 0? Yeah, because 3 times 0 is 0. So then 12 is equal to 12. Good. Next one. All right, -1, -1. So when you have the answer. All right, Mary Angela. Less than. And how did you figure that out? And you get -2 plus -3. And regardless, when you add them, it's going to be negative, right? Which would always be less than a positive. All right, last one, -5 and 10. All right, sum up when you have an answer. Oh my God. Okay, Peyton. All right, so let's see. So what did you get for when you plugged it in?
That's 1 times 20.
All right, so 2 times -5, -10, 3 times 10 is 30. Combine that, we get +20. Is 20 greater than 12? Yeah. So then yes, that is for you greater than. All right, so remember, plug in both numbers. They just have to make the statement true. This time you guys got to pick the sign that does make the statement true. So good job. It is 10 o'clock now, so we're gonna pause lesson 21. We'll finish it tomorrow. And we're gonna take our quiz now. For lesson 18 through 20. Remember that you can use your notes.